Good morning, cherubs. Well, the next little video clip I want to give you is one on how to calculate changes in concentration. So a change in concentration can either be a dilution. A dilution is going to be less concentrated, usually because we add water. The other possibility is that we end up having something that is concentrated. In other words, it is more concentrated, and this can be because we add more solute or we remove water, usually by heating and evaporating, such as when they make concentrated fruit juices, for example. They heat it up and they drive off the water. So with a change of, let me stop that, with a change of concentration, pretty much what we have is we have a first bucket with a certain quantity of water, and we have a certain number of solute particles dissolved in our water, and so we have a concentration. Our concentration is the number of moles over the volume. Because this is our first container, we'll call it concentration 1, and we'll call it the number of moles 1, and we'll call it the volume 1. And what happens is that, let's say we add some water to our container, we're going to end up with the same number of solute particles in our container, but this time our volume is different. So here we have concentration number 2, which is the number of moles 2 over the volume 2. Now what we can say is that in the first container, the number of moles in the first container is the same as the number of moles in the second container, or the second solution. They haven't changed. We have simply changed the amount of water, and therefore we've changed the concentration. So if we were to rearrange this, N1 is equal to C1 times V1, and N2 is equal to C2 times V2. In other words, we could say that C1 times V1 is equal to C2 times V2, and this is a little shorthand form that you can use, a very short little formula for working out changes in concentration, whether it's a dilution or whether it's a concentration. This is a lot easier to use. You won't find it in very many of the textbooks, but it's very easy to use as a wee method. Let me show you how. So let's say that I've got a solution. I've got 250 millilitres and my concentration is 0.1 mole per litre. And so I've got some particles in here. And I add 250 mils of water. In other words, I've now made my solution 500 millilitres. Now, the number of particles in there should still be the same. I've only changed the amount of water. Let's do a bit of an estimation, a guesstimate. I've roughly doubled my volume. I'm expecting that if I double my volume, I should halve the concentration. I should get about 50% of the concentration. Let's see how this formula works. So C1V1 is equal to C2 V2. What I'm trying to find is C2. So C2 is C1 V1 over V2. I put in the numbers. The first concentration is 0.1. The first volume is 0.250 litres. My second volume is 0.5 litres. So what I should get is 0.05 mole per litre. Very, very easy to do, step by step. Let's have a look at a different form of this. If, for example, I'm wanting to make up a standard solution, and this is where I would tend to use this more often. Let's say that I've got a bottle of acid and it's 13 mole per litre. Put a cap on it because it's dangerous. So this is concentrated hydrochloric acid, and I want to make up in a large 2 litre measuring cylinder 0.1 mole per litre hydrochloric acid that we're going to use for volumetric analysis in the lab. So I want to know how much HCl do I need to put into my volumetric flask to make up my 2 litres of 0.1 mole per litre. Well, again, I'll start with my formula. C1V1 is equal to C2V2. I rearrange it because what I need to know is V1. So V1 is equal to C2V2 over C1. I poke in the numbers. The final concentration is 0.1. The final volume is 2. The initial concentration is 13. And when I put all of those into my calculator and crunch the numbers, I will get, and it's on my piece of paper, 0.0154 litres, or 15.4 millilitres. And there I can, with a measuring cylinder, measure out my 15.4 millilitres of concentrated hydrochloric acid, put it into my measuring cylinder, and then make it up to 2 litres. And there I now have 2 litres of 0.1 mole per litre standard solution. I hope that makes sense for you, and I hope this little formula here, C1V1 is equal to C2V2, will be very, very useful for you. It's very quick, it's very easy to remember. Little trick from Mr. Tort. If you have any questions, don't forget, message me or email me, and happy to help out. Bye for now.